programming engineers. Welcome back once more to this drives course. And today's topic is going to be our very famous auto tuning. I say famous because many people know about this, but famous because it's the only thing missing to avoid many issues on the field. Now, what do we have here? We have our drives, and we need to choose this model because basically our drives are exactly the same. They're all working towards auto tuning, but in this case, Delta runs at random. So in this case, if we choose PowerFlex, Yaskawa, or the HNC, which is Chinese, it really doesn't matter. Because it doesn't matter, the brand, it doesn't matter. You need to find the tuning. Okay, so with this functionality that we already checked in our previous class, you're going to notice that it's very important. So, in reality, how can we set up this parameter? Because here it says, well, motor parameter auto tune. But how do we tune it, really? So we have a drive where some engineers can calculate or emulate with our MATLAB software, and they say that it's excellent. But remember that our drive is helping us by running all these calculations much quicker and obviously more effective because our drive already has something physical. With the shaft, with the movements, everything is already connected. So our drive is calculating according to what we have connected, okay, which in this case is our motor. Now, what happens with our MATLAB? So it needs to have the inertia data, the load, the weight, and everything else as exact as possible. So therefore, the drive, when it runs the test, it's according to what it already has. So that's why the easiest way to do this is through auto-tune. So if you want to run an auto-tune, then you need to get this data, enter them in the MATLAB software or whichever one you know for our control, especially for the earnings that we have. And then getting the most precise data to enter them to know which one we're going to affect. So this is for a finer tuning. However, we are going to use our most famous one, which is auto tuning. So I recommend this first option so that you can start adjusting the manual gains. When it's a manual tuning, you need to identify which ones you want and which ones you need. For example, in our motion control part, or right here even, if we had something, an intercooler connected, what we would need to do is to know what I need. What's missing from my drive? Why can't I load as much weight as I want? What's missing? So then, how am I going to affect it? Which one am I going to affect? So we can start compensating this. For example, if we need precision, we need to hit our position loop. If we need torque, then we need to hit our torque loop. And the other ones, since they're manual, we have to start using them. But this is the finer tuning part. Okay? But on our drives part, now we're going to go to 5.00. And here it says there's no real function. So therefore, which of these options am I going to use? We have my motor functions for my induction motor functions. And then I have my other option with permanent magnets. And the other options are for magnet control different sensors. And then the other option is for a higher frequency, which is only for testing, for our permanent motor magnet. So we don't have anything connected. And the most general one, what we're going to use are these both. So if I'm going to use more permanent magnets, then I'm going to use a servo. But it's going to depend on its individual decision. So therefore, which one am I going to choose? The static part or the dynamic part? Which one runs better? So I was explaining this in our previous videos, but this is where I'm reaffirming this. Our static test or auto-tuning, static auto-tuning, as its name says, is not going to run any type of motion or movement. So here is our shimmy. It's going to run its static test without moving. So it's something pretty short to do, but however, it's not the most recommended option unless we can't uncouple the load. Because probably for all you mechanics, it took a couple of days for the load to load. So it probably needs something larger, and maybe there's nothing, not much behind. But then the automation part and the line is what this needs and what it's going to take its time. So therefore, we need a static test. Now, this is already a coupled load. So for example, let's suppose that we have something here and the shaft is already attached. But if it's larger, it gets a little bit overcomplicated. But you guys already knew there was going to be a bit more complicated process. So you need to be very careful. So then how does this work? So I'm going to hit enter here. And first I'm going to choose the static tuning. So it's telling me by default it's not going to listen to my speed part or my velocity part. So it's not going to listen to my button box or my keyboard, because then it's going to be for external digital input. So what's going to happen here? I need to press my start button only. And here my drive is indicating that it's tuning. Okay, so I'm going to close up on this. Now, this tuning is not moving my shaft. It's running its calculations actually for gains. And it's doing the most possible so that this is adjusting. Now, this doesn't last as much because the trials themselves, the tests, are not the gains, the full gains to calculate our slide. So inertia is not as much, okay? It's only about calculation. And it's doing the most it can, the drive and the motor, to set up. So after this ends, then we can use our drive normally, okay? So we see that it works. Now, this is the first tuning. So test it. If it doesn't work, that's where our motor is going to continue with our load. and it's going to adjust to 0500 or to the point where it says indicates dynamic test. Okay, so here we go. Now it changed its frequency, which is the frequency that is set by default. The one that is considered, or that the drive considers that the brand is ideal, so that it runs the tuning test. So all we need to do is we need to press the start button once only. Now what's going to happen here? We are going to let it run its corresponding testing. As its name says, dynamic tuning. It's absolutely necessary to swing or turn the shaft. So in theory, it can start running its calculation. It can start injecting voltage. So it can see which voltage is necessary to run the inertia calculations that are adequate, that are right. I'm not doing anything. It's automatically moving. So it's saying it is tuning. All gains are tuning. Please give it a moment. And it's going to take a little bit, maybe 2 to 3 minutes. Some brands take even 1 minute. Other brands I've had that take more than 5 minutes. Let them do their tuning, because this is the most unsafe part. Okay, because here is going to be our movement. So try to unload the load. Now, in case you have it loaded, do not allow it to crash into anything, okay? Because if it's, for example, if it has a shimmy, remove the shimmy and let it do its movements. Because right now, for example, apparently it's done tuning. Until we see here in our display that it's done, or that it's already in its regular state, which is its F for frequency, then it's going to indicate that it's ready to move. But it's not respecting anything right now. So until that happens, we are not going to be able to control. So we're going to let it run its test. So let me just focus this. And our motor is not moving. So it's only running with its inertia calculations, but everything is here inside of our motor. Now, once this is done, our drive already has that information, and now it's easier to get a bigger and better control. Now, what would happen if I wish to, for example, tune? I would start this. I can start tuning once more, but guess what? It's going to give me a flaw. But let it run, okay? And tell that to your bosses or the people you work with. Remove the failure and run the same thing. So if you tell them, sir, or Mr. Plant Manager, or whatever company is hiring me, please let it set up. It will be worth it. Trust me. When a motor cannot move its load, this is the best way to adjust it. Now, here, once tuned with the gains that had already been adjusted, then now maybe you can't see this, but with a load, if it needed some potency, let's see here, let's try to do the most velocity available. It's much more efficient, okay? Now here, this is already set at max speed. And here we go. We stop this. And our control is exactly the same. So having said this, this is how we tune our drives. Doesn't matter the brand, but remember, you need to find the auto-tuning parameter. Okay? And then you need to look within your options or your configuration, your setup. Which one should we enter? If it's dynamic or if it's static. Remember, you need to let the shaft turn, but unload it. That's the first priority. Do it this way. Okay? there's no real possibility to, if there's no possibility to remove the load, then run it, at least run it very safely, because as you've seen, the motor does not care if it has a limit. The motor is still going to turn because it's running its testing. So if you're carrying something, please don't allow it to crash. So you have to tell it mechanically that it doesn't hit anything else. And especially because this is setting up at an intermediate speed. So if you guys start, or if you have an application, or if you have a crane, and if it starts running its synchronicity upwards, and it's already set. I mean, these are things that are very logical, okay? Because you can make any mistakes are always possible, a possibility, okay? But if that is the case, stop this. Stop it. Do not allow for any accidents to happen. And then, if you really can't make it turn with or without a load, then you can't run the dynamic test. So then there would be nothing else to do. Test it out then with the static part. Now, something else completely. If you guys think that you're not going to be able to move your load, or that it's going to take a little bit longer, then try it with the static test. Okay? Tell your customers or your bosses or whoever they are that before they uncouple the load, if you can run a very, very small test, so that this way you can run your sort of movement. Now, run the test, and then we could say that it would be possible, and all we needed was an extra push and some maybe adjustments in the internal gains, so that now we would be able to remove this charge. I mean, you can be saved and you could only use this, but if it doesn't work, if that doesn't work, then work with this. So allow for the axis to move the motor. And then finally, if these options don't work, for most cases, it should be capable, or the capability should be to change, or that the reducer either changes, or if it doesn't allow for a reductor change, and if it's pretty big for the coupling, it will not be able to run with its regular load. So the most obvious one is to change the motor. And if you change the motor, which one are you going to change? Your drive. So be very careful with this, guys, so you won't go overboard with anybody else's money. So my recommendation is, first, if it doesn't work, start off with our motor, and then run these tests. If it works, please send me a comment and I will be very thankful for this. Send me some comments regarding your experience. Now, the methodology and everything that we had used in our previous videos, all the connection part and the frequency test and everything else, please check them out. In case it's possible, if possible, without any loads. Test it for running forward, running backwards. Test everything. If you have the opportunity, do the dynamic testing. Because maybe it needs a little bit more potency, and I'm not going to be able to allow it to work. Okay? If the application is very simple or very small, like for example, the one that we have here for our trials, for our tests, so then you guys can consider without doing both. . So if the load is pretty big also, or if it's very heavy, or if there's a lot of inertia that's been generating, then run the tuning. Configure this and run your your dynamic auto tuning. Trust me, guys, it's going to save you guys a lot of trouble. And you're going to make good on congratulations. Okay? Now, having said this, I will now say goodbye and move on to my next video. Big hug, guys.